Welcome back after the break. Hopefully, you are all are enjoying basic idea about blockchain technology, and our dynamic officer, Mr. Naveen Naga from Bangalore, try to deliver here best from him side. And any question, any doubt, you first ask, then we go ahead or further remaining part from Nagaji. All are ready? All are ready for now start the session? Yes, Mohan sir. Okay. I response received from participant for restart the session again. So again, welcome back, Naveen Nagaji, and you can proceed remaining part of today's session. Welcome from LTTC and from APT participant. Yes, Naveen sir.
So thank you, sir. So I'll start sharing the screen here.
Yes. Now you can start.
Okay. Right. So let me continue from where I have stopped before the break. Right. Just a minute. Okay. So I hope it is also audible. My voice is audible to all.
Yes, your voice is clearly audible.
Okay. I'll continue. Okay. So till now we have discussed theory about what is a blockchain, how blocks will be there. Till now I have shown like block means it will look like this. It will look something like this. But actually, in practical or in practice, the block will not look like anything like what I have drawn a 3D block or a 2D just a block. It will look like this, something like a piece of data. For easier assumption or for easier understanding, let us consider that this is a block. As I told, a block in a blockchain contains data, hash, as well as previous hash. But for now, let me take the previous hash aside. Let me continue with data and hash. Okay. Now, here, as we can see, the data which is present inside the block is hello. So it has generated a hash, right? So actually, we are using SHA-256 algorithm here. SHA means secure hashing algorithm. Then what is this 256? 256 means here we have typed hello. It will give out a hash which has 256 bits long. If I type in hello world or something else, it will give out hash of same 256 bits. If you type your complete life history here also, it will give out the same amount of hash, that is 256 bits. That's why we call it as SHA-256 algorithm. So here as an example, I have typed hello. It has given a hash. Now some people will try to count these letters and see whether it is having 256 bits or not. For them, let me clarify. This will not contain 256 bits because it will contain 64 letters or alphanumeric numbers, alphanumeric elements here. Why? Because those 256 bits will be in binary. It will not be able to fit in this small thing. So just for visualizing purpose, that will be reduced and represented in the form of alphanumeric. You can see even alphabets are here present in this hash. Alphanumeric format with 64 number of digits, alphanumeric digits, right? So for now, think that SHA-256 algorithm is used to produce a hash of 256 bits. What if we use let us say like there is a hash, there is an algorithm of SHA48. Let us think. I'm not talking about there is there. Let us think that there is an algorithm SHA48. If you use that algorithm for what is a generating hash in a block, it will give out 48 bits of hash for any amount of data present in the block. Similarly, SHA256 algorithm will give out a hash of 256 bits here. Okay. Now, that 256 bits, binary bits, are represented in a 64 digits of alphanumeric code here, just for representation purpose. Now, what if I change this hello into something else, like have a nice day? Okay. What if I change that data present inside the block from hello to have a nice day? Whether the hash will remain the same? No, because as I told, hash is unique for a set of data. Because the data has been changed here, the hash also has been changed here. See, let us see just last three letters. It is 824 here. Here it is F64. What if I placed one here? Hello one, let us say. If I put hello one here, even for the minute change of adding a single letter in this, the hash will change. Okay. So with this example, you can see like for a different set of data, the different hash will be generated, right? Right. Now, in practice, here in the example, I have just considered data only. I have not taken previous hash into the account for generating a hash. But in practice, there will be something called as nonce as well. So to produce a hash for a block, what will happen is the data of that block will be taken plus previous hash will be taken plus along with this, there will be something called as nonce. This is a random number. Okay. All these three together will be used to generate the present hash. Okay. So let us see the same thing with the help of a flow chart here. Right. Now let us say this is the proposed block. This block is secured using SHA256 cryptographic hash algorithm, that is which we are using here. Now, as I said, nonce is used, previous block header, that is previous block hash is used. Nonce, for the definition of nonce, you can see here, nonce is nothing but a cryptographic nonce is an arbitrary integer that can only be used once. As I said, it is a unique random number. Okay, so nonce, previous hash, present block data, all these things are used here. All these things are used here to produce a hash number. Now, after producing the hash number, this is not the end of the story. After producing the hash number, we have to verify whether the hash produced here is a valid hash or not. So for that, after generating a hash,
अच्छा यहीं नीचे ना बैठा करो, क्या ऊपर जाता हो? यहीं सोया करो, यहीं या नहाया धोया करो। चलो अब तो नीचे खाली हो गया मम्मी।
okay, so some voice is coming from some other mic. Please mute yourself, all the participants, so that others also can hear clearly. Okay, thank you. Right now, as I said, let me go back to the process. First, nonce, previous hash, present data. All these things are used together or combined with the help of SHA256 and a hash number is generated. After generating the hash number, this is not the end of the story. This will be verified whether the hash is less than the target value or not. What is the target value? Target value is a threshold determined by mining difficulty that the hash must be less than for a proposed block to be added to a chain. Like this target value, what is this mining, and all these terms will be discussed further in this presentation. For now, let's understand that after generating hash, it will be verified whether this is less than target value or not. If it is less, yes, the proof of work have been achieved and the new block has been verified, approved, and this block will be added to the existing blockchain. This is how a new block will be added. Whereas if the hash is not less than the target value, then what will happen? It will go to this particular path, again increment the nonce. nonce will be incremented. Now it is 2375, right? It will increment it to 2376. After incrementing it to 2376, again it will try to generate a hash. After generating a new hash again here, it will be verified whether it is less than the target value or not. If it is less than the target value, proof of work is achieved. This process will go on and go on further until the proof of work is achieved. So, with the help of this explanation, I hope that everybody might have understood generating a hash or validating a block is not a simple task. It is like going through number of iterations to find out the correct hash, which is less than the target value, means which will achieve the proof of work. And this, we can simply say that this is a kind of complex mathematical puzzle which need to be solved to find a correct hash, right? So this is the flowchart of doing so. Now, let us say, now I'm taking nonce also into the considerations. Now this is block one. Its nonce is something like this, and the data is test. For this set of things, the hash that is generated is this. Okay. Now consider a block in a blockchain with the above data with valid nonce and hash. It is, I'm saying this is a valid block because for this set of data, this particular valid hash is being generated. Okay. Now, if I change this test into good morning, please make a note here saying I have not changed the block number here and here, right? Next, I have not changed the nonce. Here it is 156384. Here also it is 156384. I just have altered the data present inside the block. Here it was test. I changed it to good morning, right? Now, here you can observe that hash has been changed here. 15 AC90. Here it was 43760. Though hash got changed by itself because we have changed the data present inside this block, because it has not yet been validated, it will be called as invalid block. That's why it is showing in red color here. Whereas in the previous case, it was in green color, right? Now, as the data inside the existing valid block is altered, it is showing that it is invalid as the nonce and data together are not complying with the hash below. Okay. Hence, it is considered to be invalid and the block is not accepted by the peers because it is invalidated. How to make it valid? To make it valid, we have to press something called as here mine. We have to make a process or we have to execute something called as mining here. So once we mine, for this set of data, a new nonce will be generated and a new hash will be generated. By generating these things, we can make that particular block as valid block. See, now as previously explained algorithm, the proof of work has been done and corresponding nonce is found and hence a valid hash been generated for the block and the block has become valid now. I hope this is clear for you all. Right. So let me go to the next slide. Working of a blockchain. Till now, what we have discussed in the working of a blockchain, we have discussed what a block contains, how a hash will be generated for a block, what if we change the contents of a block, how the hash will be changed. If you want to validate the block, if you want to make the block valid, what we have to do? We have to mine it so that a new nonce will be generated for that particular set of data and a new hash will be generated which is valid. Okay, next. Let us see how it works in terms of theory. Okay, blockchain is a concept of decentralized network and a distributed digital ledger. In this ledger system, legitimate and secure transactions can take place from a point-to-point exchange as a point-to-point exchange. This is the same thing which I explained previously. From one point to another point, the currency transfer or transaction may happen securely and in the form of distributed ledger and a legitimate and secure. Got it? Next. Blockchain is a system of multiple nodes or computers which act as a distributed network over the internet worldwide. Each node has the authority to make a transaction, verify a transaction, receive a transaction, and create a block. Here, please make sure that the node which I am talking here is a validator node, not a member node. Member node can only initiate a transaction, it can receive a transaction. That's it. It can't validate a transaction or it can't verify a transaction and create a block. Okay. It can't verify a block actually. It can verify transaction, it can't verify a block member node. Whereas validator node can do all these things, right? Next, the blockchain is a cryptographically linked chain of blocks, that is set of records, such that no one can falsify or modify the data stored in it. How can I say this statement? With the example which we discussed earlier, that if a tracker, if a hacker tries to hack a system and try to change the data present in a blockchain, what will happen? We have seen. So now I can say this statement with confidence that no one can falsify or modify the data stored in it. Okay. Now, just a minute. Okay. Now, once we enter a set of transactions in a blockchain, then it becomes a part of it forever. Just a minute. There is some technical issue, I think. Now I hope everybody able to hear.
Yes, audible.
Yes, yes. Sir. Now, 1 minute, sir. Sir, there is some small technical problem. I'm not able to change the slides here. Give me a minute. Okay. 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 So sorry for this thing, small disturbance. There was a issue with this internet connection. Now I hope that you're able to see this, what I'm explaining here.
Yes, both annotate
Yes.
and your voice is clear.
Yes, yes, right. Thank you. So I'll continue with this same session. Now I have left the session here. So blockchain is cryptographically linked chain of blocks, that is set of records, such that no one can falsify and modify the data present in it. Like once we enter a set of transactions in a blockchain, then it becomes a part of it forever. Now, each node on a blockchain network has a separate copy of this ledger or database. This line is very much important because, as I said earlier, the same copy of the ledger or the database or the blockchain will be maintained all across the nodes in the network. They can access the transaction history on the blockchain whenever they want and get it updated every time a node adds a set of new transaction into the chain. So let us look at this process more clearly. Think that there is a node A, there is another node in the network, node B. Okay. So they want to transfer data from node A to node B. Now, how this transaction will happen? This transaction can happen only if all the participant nodes in the network verify it as a legitimate transaction. Don't think that this is validating a block. This is validating a transaction. So every node in this blockchain network will make sure that this transaction is legitimate. Means, for example, in the same example which we discussed earlier, this person wants to transfer some 2000 rupees to this person. First, these nodes will verify whether this person is really having 2000 rupees in his account or not. Means they are playing the role of a bank generally. Now, and other things also will be there. Whether the transferred party and the transferring party, means what do you say? The node A and node B are properly defined or not, and node A whether it has the proper balance in this account or not. All these things will be verified by all the nodes in this network. Once they verify, it is called as a legitimate transaction. Thus, each node will receive a request to verify the transaction to happen between A and B. This initial step, once they verify the transaction, each node will check a certain points about the transaction, such as authenticity of the two nodes. Is the transaction amount within the limits? Does A have sufficient funds to make this transaction, etc.? Like what I have told just now. Okay. Now, after doing this, nodes will verify or will verify this transaction as legitimate one. Remember, this is not validating the block. This is just validating a transaction, right? Next. Once all the nodes check and verify all the aforementioned points, the transaction is ready to take place. Now, this is not the end of the story again. Then the transaction gets added into the memory pool. Initially, when I was talking about history of blockchain, I referred to it as before introducing something called as miracle trees. One transaction will have a hash, another transaction will have a hash. We don't know the method of combining these two transactions into a single hash. But with the introduction of the Merkle trees, we are able to combine all the hashes of different transactions and generate a single hash, and they can be made into a block. So after recalling that concept here, this particular transaction, verified transaction, will be placed inside something called as a mempool or memory pool. Memory pool is not a block again. Memory pool is a part of a block. And see, these are all, this is a verified transaction, this is a verified transaction, this is a verified transaction. All such verified transactions will be kept inside something called as mempool or memory pool. Then there will be something called as particular amount of data that can be stored inside a block. When several such verified transactions get aggregated into mempools and multiple mempools combine together to make a block. Now, because every block has a defined memory limit to store the transaction, once that limit is reached, then we can say that a block has been, means the sufficient amount of memory to create a block has come. Now we are able to move further. Now, once we got the sufficient number of transactions, the sufficient number of mempools to make it into a block, every new block will have a block header that consists of data summary, timestamp, hash code of the previous block, and its own hash. Means if you think that this is a block header, this will contain data summary, whatever the data that is present inside that block, the summary of that. Next, it will have a timestamp at what time it is created and on what date it has been created, previous hash code, previous block's hash, and the hash of this particular block, and nonce. Now, every block has its unique hash code, which acts like its fingerprint, which we have discussed earlier already. So, in the next further step, in order to add a new block into the existing blockchain, now this system, which wants to, let us say, this system, which wants to add a new block to the corresponding blockchain, is ready with the block. But to add the same block across all the nodes, what we have to do? what need to happen? First, in order to nodes in the network need to do something called the same thing we discussed previously in the history of blockchain, something called as reusable proof of work. Similarly, here, a simplified version, or we can simplified name, we can say. As we know, each block has its unique hash function, which is used as an identification code created using SHA-256 algorithm. Doing proof of work is decrypting this code and finding the correct answer to the hash puzzle. If you consider generating a hash is kind of puzzle, we can say like doing the proof of work is decrypting this code and finding the correct answer to this hash puzzle. To do proof of work, we need specialized computer that take on an average of 10 minutes to crack the code automatically. Okay. So I am telling it will take around 10 minutes to crack that code and generate a valid hash. Okay. Now let's move further. A block gets verified at every time a node completes its proof of work and finds the correct answer to the hash puzzle for the block. More and more nodes must verify or complete the proof of work for the same block so that it finally gets added to the blockchain. Every block has a unique set of transaction records. To create a new block, add it to the blockchain, one must have a completely unique set of transactions in there. So this is how blocks will be added to the blockchain and how the block has been formed. With this, new block gets added and transaction is completed between points A and B. So let me summarize all those things which I have told till now. First of all, as I told, the same replica of blockchain will be present with all the nodes. Now, this computer wants to add a new block here. Okay, all are connected with a set of rules called as consensus, which we are going to discuss later. Now, this block wants to add a new, this node wants to add a new block into this chain. What it will do first? First, it will broadcast this block across all the network. Once all the validator nodes, here I'm assuming that all the nodes are validator nodes only, and I'm not considering any member nodes here in this network. Okay. Now, once all the validator nodes receive that particular block, what they will do? They will start solving the puzzle. Means they will start changing the norms and they'll start generating a hashes and validating it, whether it got whether it is less than the target value or not. Once that is achieved, then the particular valid hash is generated. Then the block gets verified and the same copy of that block will be stored everywhere across the node. Now, ultimately, when you look at the complete picture, you can see that the same copy of blockchain has been stored everywhere across the network. The same copy of blockchain has been stored. This is how a new block will be added to the network. New block will be added to the chain across the blockchain network. Right. Now, let us go further in this presentation. Consensus algorithms. So first of all, what is a consensus algorithm? Consensus algorithm, as mentioned, it is a common set of rules. So if you ask me to give an example for consensus algorithm, simple, something that we talked till now, something called as proof of work. Why proof of work required? This why consensus is required? Because blockchain is a decentralized platform. To make all the nodes work according to a set of rules, common set of rules, we need to define them. That common set of rules is called as consensus. Okay. Now, blockchain, which are distributed databases, the network nodes must reach an agreement on the network's current state. They should reach an agreement on which is the valid set of blockchain, how a block will be validated, how the validators will act. This agreement is achieved using consensus mechanisms. Now, consensus mechanism has some characteristics. First is consensus mechanism is secure. Okay, so a consensus protocol is defined to be safe. If all the nodes offer the same output, outputs are valid as per the rules. So let us not going too deep into these things. For now, let me give an outline of this, saying consensus mechanisms will need to have some characteristics. That is, first is security, next is fault tolerance, next is real-time value. So a consensus protocol has three basic features based on which its efficiency is determined. There are so many consensus protocols. If you want to determine which consensus protocol is better in terms of something, and if you want to define some other consensus protocol is better in terms of something else, it will be determined by looking at these three basic features. Next, Let us go deeper into this consensus mechanism. The first type of consensus mechanism is proof of work, right? Now, when a new block need to be validated in the blockchain network, the node start calculating the hash for the block. Ultimately, the one who calculates the correct hash or validates the new block first will get the reward. So let me explain this example with the help of some small this thing. There is a node here, 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 there is a node here. All these nodes are ready and they are thinking to validate a new block. Like this member, this particular node has requested to add a new block to this network, existing blockchain. So this blockchain will be broadcasted to all these nodes, and every node starts trying to validate. Every node starts to validate. Why they want to validate that particular block, or why they want to add that particular block to the chain? Because if they validate that particular block successfully, they will get a reward. Okay, in order to get that reward, it may be Bitcoin, it may be transaction, it may be transaction fee, it can be anything. But ultimately, in order to get the reward, everyone starts everyone starts trying to validate that particular this thing. Okay, so when everyone work, okay, so when everyone starts trying to validate this block, ultimately only one person will be successful. Let us look at this scenario with the help of some example. Let us think that there is a kind of like running race. Okay, so all the participants who want to participate in this race start running towards the finishing line, finish line. Ultimately, only one person will be able to make it. He will be called as a winner. He will be rewarded. What about other people who has run this far? The second person might have missed the medal with some 0.2 seconds, something like that. What about the person who came third or fourth, or who let us consider the person who has come last also. Even he also might have run some distance. So whatever efforts he put in to reach that will not be taken into consideration. Only who is able to successfully cross this finish line will be considered as the winner, or who will be considered as a validator in this example, means successful validator in this example, and he will be rewarded in terms of cryptocurrency or in terms of transaction fee. Okay, so this example is nothing but proof of work. Once a block comes for validation, everybody starts running, everybody starts trying to solve the puzzle, everybody starts to validate that block. Ultimately, a single person will be able to successfully do this feat, and he will be able to get the reward. This is called as proof of work algorithm. Next, proof of stake. Now, in the previous example which I have told, even though all the persons, all the racers have run that far, the energy will be wasted because they have not won the race. Similarly, although this nodes which has put so much of power, is energy, electrical energy, let us say, and so much of processing power into solving this particular hash puzzle or trying to validate that block. Ultimately, if this person wins the reward, the energy which has put, or the processing power which has put into this process from these blocks will be wasted. They'll get nothing in return. At the same time, all that energy will be wasted. So there is so much of energy wastage in proof of work algorithm. To avoid this thing, something called as proof of stake has come into picture. Okay. Now, what is this proof of stake algorithm? In proof of stake algorithm, what will happen is, I'll take the same running race example, which will make things clear here. Before they start the race, before they start the race, they will decide among themselves. First of all, they will decide first who will run. Means I'm talking about a race where only one person will run, only one person will win. So first they will decide among themselves who will run. Let us say they have decided this person will run. Oh, only he will run. He will is the finish race. He will get the reward ultimately. So you may get a doubt here. Why these people has not, what do you say, said like they want to participate in the race? Why they have allowed this person to run instead of themselves? Means to avoid this thing, what happened is here only one validator is given chance to validate the new block, right? That is, one is decided by the amount he locks as a stake. Every person will put their stake. For example, this person says, I am putting $5. He will put $6. Let us say he will put $10 as a stake. This stake will be locked in. Okay, this stake will be locked in until he completes this validation. Once he logged, whoever bids highest stake, he will be decided to run. He will be decided to validate that. If he is successful in that validation, he will get reward. If he is unsuccessful in this validation, because he has wasted this much of time, he will be penalized. Among out of the money which he has logged, means amount among the stake which he has logged, only some amount of stake will be given back to him, whereas some amount of stake will be kept with this network itself, and it will be used to reward other people. Right? So if you see here, you can understand that here only one person is running, means only one validator is trying to validate the block. Other nodes are not trying to do that because they have kept lower amount at stake. So ultimately here, so much of energy will be saved, so much of power will be saved. So if you look in environmental protection kind of view, proof of stake is better. If you look in other kind of view, which we discuss later, which will be better in terms of this thing. Now, let us see next thing. Let us compare this proof of work and proof of stake. Okay. First of all, to add each block to the chain, miners must complete to solve a difficult puzzle using their computer's processing power. Whereas in case of proof of stake, there is no competition as the block creator is chosen by an algorithm based on the user's stake. Right? Next. Next. For example, for a hacker to hack or to change, to add a malicious block into his network, he has to have access to more than 51% of the nodes in the system or the processing power, or he needs to have a computer which is more powerful than 51% of the network. He should have most powerful computer with him. Okay. In case of proof of stake, in order to add a malicious block, he or the hacker has to have more than 51% of all the cryptocurrency of the network. Let us say there is a cryptocurrency platform where there are some 100 bitcoins. Let us say, okay. Now, if for a person, for a hacker to add a malicious block into this platform, he should have at least $51 with him. If he has $51, what he will do? For validating a new block, he will put this complete $51 as stake. So automatically he will get chance to validate that. If he is able to successfully validate that, he will get reward. Right? Ultimately, he is able to successfully add a malicious block. This is what I am talking about now. Right. Next thing is the first miner to solve the puzzle will get a reward for their work. Here, there is no reward for making a block. So the block creator takes a transaction fee instead of a this thing. Next, POS is better than POW in terms of lower energy consumption because ultimately only one person runs. However, it is largely untested because the most famous Bitcoin network, which we know all know, works on proof of work consensus algorithm mechanism. Got it? So there are even more kinds of consensus mechanism. That is delegated proof of stake. In this, what we will do is a person rather, for example, if he thinks he don't have that particular computing mechanism with him, sufficient mechanism with him to solve that puzzle. So what he does is instead of solving the puzzle by himself, he will delegate some other person who has powerful computer with him by putting his money, let us say $10, at stake and delegating him to solve the puzzle. This is called as delegated stake of work, delegated proof of stake. Instead of putting stake for himself, he will put stake for delegating some other person who is having better processing efficiency, let us say, to solve that puzzle, so that ultimately the puzzle will be solved successfully. Because he knows if the puzzle is not solved successfully, if that hash is not generated validly, ultimately he will be penalized. So this is delegated proof of stake. Blockchain projects like EOS, BitShares, Steam, Tejo, etc. will use this algorithm. Okay. Next. proof of elapsed time. Here, what will happen is if there are some particular nodes, every node will be given a timer. Every node will be given a timer. So this timer, all these timers will have different, they'll be running in different times for every node. So ultimately, one particular node will be selected randomly whose ever timer expires, and this is called as a random leader selection. And he will be given chance to validate that block. Again, after validating, his timer will start again. Countdown timer will start again. This proof of elapsed time consensus algorithm was actually developed by Intel to solve a computing challenge of random leader election. Next, similarly, as I told, this node will have some countdown timer. 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 Ultimately, whoever timer gets gets filled first, whoever time elapses first, he will be given chance to validate that particular node. Once he validates, he will get reward. Proof of authority. Proof of authority algorithm is based on the value of identities within a network, and it was actually conceptualized by Ethereum co-founder and former CTO Gavin Wood in 2017 itself. It means when a block comes for the validation, the chance of validating that particular block will be given to a particular person who is most trustworthy. You can think of a 5-star rating. Just I give here for example, because this person has a 5-star rating out of 5 compared to these other people, he will be given chance because he is the most trusted. He will be given chance to validate that particular block. How he will get this 5 stars? Because based on the number of successful transactions he did previously, he will get this particular star rating. Let us say he will get this person who is having a 3-star rating. He will try to successfully solve the puzzle. I'm not telling that he only will be given chance to do that. He'll be given what are the disadvantages of this blockchain. First is pros. It is trustable. It is secure. It is open and transparent. Anyone can participate in that. It will have lower transaction per second, means it will be slower compared to other blockchain. It has scalability issues. It has high energy consumption, etc. When you look at private blockchain, the examples are Hyperledger Fabric, Carda, and Sawtooth. These private blockchain networks are deployed for voting, supply chain management, digital identity, asset ownership, etc. They'll be so they're restrictive or permission. In case of open or public blockchain, there will not be such things. In terms of for the private blockchain, what are the advantages and what are the advantages? Is speed, scalability, open and transparent, lower security, but disadvantages are it will have less secure, centralization, needs trust building. Okay, next, let us look at next type of blockchain, consortium blockchain. The examples for consortium blockchain are Energy Web Foundation and R3. These are kind of semi-decentralized type, where more than one organization manages a blockchain network. More than one organization can act as a node in this type of blockchain and exchange information or do mining. Consortium blockchains are typically used by banks, government organizations, etc. What are the different various types of blockchain platforms? It can be permissioned, it can be permissionless. Ethereum, Hyperledger, R3, Ripple, EOS are kinds of different blockchain platforms. Simple city, we can say like Tejas. Tejas is a kind of blockchain platform. It is not actually based on mining. Rather, the token holders get a reward for participating in the proof of stake algorithm, in proof of stake consensus mechanism. Next blockchain platform is Ethereum, which is very much famous. It is open for public use and it is based on proof of work. It is strongly followed in GitHub. Next, R3 Corda. Just you can think like Ethereum is a platform, Bitcoin is a platform, R3 Corda is a platform. These are all different kinds of blockchain platforms. It is a collaboration of some world's largest financial institutions. Corda also explores the blockchain application in healthcare, trade, finance, supply chain, etc. It is a permissioned blockchain. Okay. Next, Ripple. Ripple also is one of the blockchain. It helps to connect banks, digital assets, exchanges, payment providers, and it will be used to send money globally with ease. Okay, it is faster actually. Ripple is faster. Next, key characteristics. What are the key characteristics of blockchain? These are all the terms which you should know before learning that. We'll look at these key terms while we go across this presentation. First, blockchain possesses a lot of benefits for businesses. Here are several embedded characteristics. First is cryptography, immutability, provenance, decentralization, anonymity, transparency. Already we know all these things. Let's look at those things a bit further. First of all, blockchain uses public key and private key. These things are asymmetric. Okay, cryptography to give users ownership over their cryptography units. Each blockchain addresses a corresponding private key. While the addresses can be shared, private key should be kept secret. This will ensure that only you will have access to your particular account, online banking, password. Immutability. Immutable means unchangeable. As I said earlier, once you enter some data into the blockchain, it can't be changed. Next, provenance. Provenance enables businesses to easily collect their data along with open data and also verify key information on an immutable data ledger called as blockchain. Next, decentralization. There is no requirement of putting or employing a central authority because this is decentralized. So ultimately, there will be less chances of single point of failure. There will be less censorship. Decentralized networks are more likely to be open development. Next, anonymity. As we will be hearing so many times, when you do some transaction using this thing, what's it, cryptocurrencies, that will be kept anonymous, right? So we can do anonymous transactions. Confidentiality of information and security of transactions will be ensured. Transparency. Blockchain makes data open or transparent in a way that has not existed in financial systems. This is why many argue that blockchain could be used as new standard for transparency. Okay. How it is transparent? Network participants have ability to access holdings and transactions of public addresses using Block Explorer, easy to search the blocks of a blockchain, their contents, their relevant details. Next, there are different versions of blockchain. Blockchain 1.0, blockchain 2.0, blockchain 3.0. Initially, when the blockchain was employed, the main feature was currency. They were having cryptocurrencies. This was one of the applications of this blockchain. When the blockchain 2.0 was introduced, it has thing called as smart contracts, as I explained previously, and what I'm going to explain later now, further in this presentation. It was having blockchain 2.0 had something called as smart contracts. Next. Blockchain 3.0 apps. Blockchain 3.0. Okay. Next. Let us go further in this presentation. First of all, when you look at applications of this, generally let us continue from where I stopped here. Let us look at the applications of blockchain. Okay. What are the applications? This is a very interesting topic here in this presentation. First of all, whenever we heard the word blockchain, we will think that it is cryptocurrency. No, actually, blockchain is not cryptocurrency entirely. Cryptocurrency is just an application of blockchain. There is way more number of applications for this blockchain tech, something called as odometer fraud. Means generally odometers will record the mileage of the vehicle. For example, a person who has used his vehicle for longer time, but he can tamper his odometer so that he can show that it has been used less and he can sell it for a higher price. This is called as odometer fraud. Rather than using normal odometer, if you employ a smart odometer, it will be frequently writing its reading, its mileage into a blockchain over the internet. So patents, notary, and also it can be used to store the land records, as I said in the previous example in the initiation of this presentation. This is possible because of the fact that any event can be traced back to its origins to verify its originality. Next, digital voting. Yes, even blockchain can also be used for the purpose of digital voting, and a Swiss company called as Agora is already working on such system. The food industry. Just imagine you have bought a product, food product. Once you have scanned the QR code on the product, you are able to get where that, for example, you have bought a pack of peanuts, roasted peanuts. When you scan the QR code present on the pack, if you are able to see where the peanuts have been grown, where they have been processed, where it has been supplied from, where the pack has been manufactured, who is the retailer which you bought it from. If you're able to get all this information from this thing itself, how good it will be. This can be achieved using blockchain technology where the particular details will be stored into the blockchain platform at each and every stage. Okay. Why it is required is something, if some, let us say like the peanuts which were taken by you is of some bad quality, or if it causes some health problems to you, you can immediately alert that company so that they will find out which batch of packs which you got it from. Those batch can be hindered or that can be stopped from circulating. That can be stopped from selling, which is very much difficult in the traditional system. So this will help in tackling this kind of situations very easily. Actually, Walmart and IBM are currently working on this kind of system. Smart contracts. This is very good kind of application for this blockchain technology, which has been used already and it has been proved to be very much successful in a country called as Finland. Smart contracts are self-executable programs that are stored in the blocks. Let me give you a very good example for this. Say, like in 2014-15, around this time, there was a huge refugee crisis. There was a huge refugee crisis. So many people from other countries have taken refuge here in Finland, started taking refuge here in Finland. It may be due to that Syria war and all those things. So the Finland has faced so much of insurge of these refugees, you can say. So the main problem of handling that is, for example, when a refugee comes into a country, the country or the government of the country will try to give money to him, cash to him, okay, so that he can use the cash to buy groceries, to buy whatever essentials required for him. But ultimately, in between this cash, whichever the government gives, may become diverted, or even though he gets that money, he will be using for his basic requirements only. Ultimately, he will not be able to serve the country, because even though he will be getting money from the government, if he wants to take some loan from a bank, the bank will not grant loan for him because is new to the country, and this bank will not have his past credit records, past transaction records. He don't have any credit score. So what happened is Finland, they have collaborated with a startup called as Moni, which used Ethereum blockchain platform. They have given cards to these people, prepaid cards to these people, through which the government will give money to this is entitled for 30% discount in grocery, some 5% discount in fuel. Next, from the second year, if he is entitled for only 20% discount in groceries, some 3% discount in fuel. Again, after the completion of first year, again these terms need to be changed manually. Rather, because the employer one more advantage is here, because the banks did not give loans to this because they don't have any past transaction history. Rather, if he lends money from his friends through this card, if he pays them back, all this will be stored into this blockchain platform. Ultimately, when bank needs to give them loan, they will check these particular things which are stored in a blockchain. They are able to give them loans. These people can start businesses and ultimately contribute to the development of the country which they took refuge in. So this is how refugee settlement and their upbringing has become faster, and ultimately they are able to contribute to the growth of the country very quickly. So this is one of the biggest application which has proved to be successful in Finland. So now with the present crisis, even Europe also is trying to use this particular system for this thing. So with this, we have discussed about all the kinds of things, how what is the blockchain, how it can be implemented, what are the types of blockchain, what are the different blockchain platforms, what are its applications, what are the challenges which we faced in this blockchain platform. These are all the things which we have discussed. So if you have any doubts, if you have any queries, you can ask with this. With this query session, we can conclude the session. So please, you can type your queries in the chat here so that we can discuss those.
So all participants are requested to kindly raise your any doubt related to the blockchain platforms and its characteristics and its application. Kindly unmute yourself if you have any query, any doubt.
Either you can unmute yourself and ask it out, or you can even type in the chat as well. Anything is fine. So one person has asked, smart contracts are only executable on Ethereum network. Actually, Ethereum networks creates a platform to execute these smart contracts. Whereas, for example, let you consider Bitcoin platform, we can't execute smart contract on that particular platform. There may be other platforms which will facilitate the smart contracts, but the most famous one is Ethereum. If you create a blockchain platform, small blockchain platform for yourself, you can execute the smart contracts in that. I hope that this has answered your question.
Anyone else? Any question? Any doubt?
Okay. One more person, Mohan Subha has asked, what technology as or language is used other than Ethereum? Actually, Ethereum is not a language. Ethereum is a blockchain platform, similar to a Bitcoin platform, similar to some other Litecoin platform, some other things. Okay, Tejas platform kind of. We can use even Python, Java. We can use to create a blockchain platform. Actually, there are so many other languages which we can use to create a blockchain network.
R programming, Scala is also, Ruby is also there. So it is not necessary. Actually, Ethereum is popular because it is available in public domain. Various companies also develop for private work also. So they not disclose their on which platform and the languages they are using. But preferably Solidity is there, and many more other languages are there. So basically, for modeling point of view, Python is also using. But in reality, when we go to implement that modeling into the real world, once again C language and C++, because they are very near to the machine language, and the execution time is faster as compared if we are working on the application layer. So Python is an interpreter. Basically, it's a kind of script. PHP is also a script. So if we are running on the application layer, definitely it takes so much time as compared to the programming languages like C and C++, which are very near to the assembly language or machine language. So I think if you develop or set up your own blockchain, then you prefer C language and C++ because they are very near to the system. Execution time is very fast rather than using any kind of script language. Anyone have any doubt? Okay, I think no doubts from any participants. So now we will close. I invite all the participants, anyone who wish to share the information regarding their country. Developed or already in use in your country. If you think that this is the right platform to discuss about that, please unmute yourself. And if you share regarding the any applications or you can say platform in running already in your country, that may definitely enhance the knowledge of other participant as well as instructor also. Okay, so no question from participant sides. So I thanks to
Hello.
Samuel Pradhan sir asking what happened to the authenticity of the ledger if there are no miner at all in the networks?
in that case, that node or you can say block has not been authenticated, so that may be dropped. If any transactions has been initiated, so miners may work on that. And as the condition raised by Pradhan sir that no miner is there, that means nobody able to validate that thing. So once if nobody validate, that means that transactions is not authenticated. So that may not add it on the database.
Okay. Any more question? Mohan sir, from your side, any question? Yes.
Definitely, sir.
Yes.
Naveen sir, please go to the next slide.
Yes.
Yes, sir. Please take screenshot. Mr. Naveen, Matam Naveen Naga, GTO Mobile, and Mr. K.karthikeya, his colleague. They both working since last 2 years on blockchain, and he is very expertise in blockchain, Mr. Naveen sir, and Mr. K.karthikeya, who expertise in digital ledger technology and cryptocurrency. So on Thursday, Mr. K.karthikeya take a lecture on digital ledger technology and cryptocurrency. So definitely contacts are available, and these PPTs as well as video also share with you. So don't worry about that regarding the materials and video. So anything else you may please raise.
Okay, and tomorrow is a presentation already share in the group, a small presentation from APT participant. So please be ready and voluntary. Any more want to tomorrow for presentation also most welcome. Any more question for today's session? You can query. Otherwise, we can conclude the session. Yes. One more question from Mohan sir. Any live blockchain application in use as of now?
In India, already there is a NPCI already run blockchain, and there is a educational from point of view. There is a CBSE, Central Board of Secondary Education, which already implement blockchain for generating the certificates. In the Hyderabad region, already PDS, Public Distribution System, as well as land record system already implemented. And they can also try to implement on the excise duty also. Presently, the Goa is the first state in India which implement blockchain concept in excise duty. That use cases covered by myself on Wednesday. The topic name is adoption of blockchain in India. We will discuss more in detail on Wednesday by myself.
Okay, any more?
So at last, I thanks to Mr. Naga Naveen sir for your extraordinary presentation. You deliver the concept of blockchain. It is very difficult to understand the blockchain, but the way you present the concept of blockchain in front of trainees is extraordinary. I thanks to Matam Naga Naveen sir for your excellent
Thank you, sir.
presentation.
Thank you.
Now, finally, I thanks to all participants to give your kind attention towards the session, and your patience also that you continuously in touch with us for the last 3 hours. It is very difficult to sit in a continuously for 3 hours, but definitely Naveen sir's presentation emphasize you or energize you that you may sit and listen carefully. So thanks to all participants.
Thank you. Have a nice day. And again, see you all of you tomorrow. Again, some more about blockchain technology. Thank you, Naga sir, Neeraj sir, and all participants.
Thank you.
Essentially, listen to today's session. Thank you for today. Thank you. Namaste.